What is compressive sensing, and how does it recover incomplete signals? Imagine trying to piece together a puzzle with only some of the pieces. How can you see the full picture? That's what compressive sensing does with signals. It helps us rebuild signals even when we only have part of the data. This method is changing how we think about signal collection and processing. In traditional signal processing, we use the Nyquist-Shannon sampling theorem. It says we need to sample a signal at least twice its highest frequency to reconstruct it perfectly. But that can mean collecting a lot of data, which takes time and resources. Compressive sensing challenges this idea by showing that if a signal is sparse, we can recover it from fewer measurements. A sparse signal is one where most of its coefficients are zero or near zero when expressed in a suitable domain. For example, in the frequency domain, many signals only have a few significant frequencies. Compressive sensing takes measurements not as direct samples but as inner products between the signal and test functions. These measurements form a system of linear equations, but with fewer equations than unknowns. Even with fewer measurements, we can still recover the original signal if it is sparse, and the measurement process is incoherent with the sparsity basis. Incoherence means the measurements spread the information about the signal's important parts evenly across all measurements. This makes it possible to identify the non-zero coefficients. The recovery process uses optimization algorithms that find the sparsest solution consistent with the measurements. These algorithms look for the fewest non-zero coefficients that fit the data. If the conditions are right, this process reconstructs the original signal accurately. This approach has practical uses in many fields. In magnetic resonance imaging, it can reduce scan times by capturing less data but still producing clear images. In communication systems, it helps transmit data efficiently by reducing bandwidth needs. In digital signal analysis, it speeds up data acquisition and saves storage space. Hardware devices like the single-pixel camera use compressive sensing to capture images with fewer sensors. This makes the system simpler, faster, and more energy efficient. In control systems, it allows for quick sensing with less power. In summary, compressive sensing is a smart way to recover signals from incomplete data by exploiting their sparsity. It relies on mathematical techniques to solve underdetermined systems, provided the signal is sparse and measurements are incoherent. This method is opening new doors for faster, cheaper, and more efficient signal processing across many areas.